In this lesson video, we are going to discuss three special movement operations inside the edit mode. First is edge sliding, second is vertex sliding, and third is moving along the normal direction, or also known as shrink and fatten operation. We need to discuss these three techniques because we are going to use them in the upcoming lessons. First, let's discuss edge sliding. A lot of times when doing modeling, we need to move an edge or edges along the existing surface. This is what edge sliding is all about. In this example, I have a tilted cylinder and a cube. Both of these meshes are already joined together as a single object. If we go to the edit mode, we have several edge loops at the center of the cylinder mesh. Now, let's say you want to move this edge loop so it is closer to the top area. We cannot use the existing axis constraints. You can keep trying, but you will never get a perfect result, even if you change this to the local orientation. Because the mesh is already tilted, there is no axis constraint that can help us at the moment. In this scenario, the edge sliding method is the best option that we have. Essentially, it will slide edges on existing surface or topology. To access edge sliding, first, make sure the edge or edges are selected. Go to the Edge menu and then choose Edge Slide. Or you can simply right-click and then choose Edge Slide here. In this mode, we can slide the whole edge loop along the surface easily. Now, besides using the Edge menu or the right-click method, there is actually a hidden shortcut for the edge slide operation, and that is by pressing G twice. So press G and then G again. We can see we are sliding these edges, okay? Another way to do edge sliding is to use the edge sliding tool, which is this tool here. If we have the tool active, we need to have the edge or edges selected. Then we can click and drag anywhere in the viewport to slide the edge. Personally, I prefer to use the double G shortcut and just have the tool mode set to move or the selection tool. In certain scenarios, an edge or edges can have multiple surfaces or faces connected to it. For example, this edge at this cube mesh. If you want to slide this edge, you can either slide it this way along this face or slide it this way along this face. Blender is smart enough to detect our mouse cursor and decide which surface we actually want to align. So if we press G twice, you can see if I move the mouse cursor to this direction, Blender will snap the edge to the top surface. But if I move the mouse this way, the edge will snap to the side face. Another sliding feature that almost similar to the edge sliding operation is the vertex sliding operation. Essentially, vertex sliding operation will slide a vertex along the existing edges connected to it. To do this, you need to be in the vertex selection mode. Let's say you want to slide this vertex. Make sure the vertex is selected. Then you can right-click and choose Slide Vertices here. We can see how it automatically snaps to the edge closest to the mouse cursor location. Because there are three edges connected to the vertex, you can pick which of these edges you want to snap to. For vertex sliding, there are two shortcuts that you can use. First is Shift-V. You can see the shortcut when you right-click or by going to the vertex menu up here. And second is by pressing the G letter key twice, just like how we use the edge sliding. Just like the edge sliding operation, vertex sliding also has a dedicated tool. If you hold and press the vertex sliding tool, you will see the vertex sliding tool here. To use this tool, first, we need to have the vertex selected. Then, we can click and drag anywhere in the viewport to slide the vertex. The mouse movement will determine on which edge you want to slide the vertex. The third technique we are going to discuss is the move along the normal direction, or officially named as shrink and fatten operation. Let's say we select this face at the cylinder, and we want to move the face this way along its normal direction. To do this, we can press Alt-S and just move the mouse up and down. we can see how the face movement is constrained by its normal direction. If you forget the shortcut, you can open the mesh menu up here, transform, and then choose shrink fatten here. We can see the shortcut is Alt S. Let me undo this. If we select this face loop and press Alt S, we can get something like this. Now, at this point, you might be thinking that this operation is similar to the ordinary scale operation. My answer is, in certain scenarios, such as this one, they both might produce the same result. But the way they work is actually very different. For example, if I select this top face and then press Alt S, we can see the face can extend or retract following its normal direction. But if we press S to do the ordinary scaling, this is what happens. It becomes bigger or smaller instead of moving the face in a certain direction. So from this example, I hope you understand the difference now. If you prefer to use the tool mode, you can access the shrink fatten tool, which is this tool here. The workflow is basically the same with the other tools. First, you need to select the mesh elements. Then, just click and drag the mouse up and down on the viewport. Drag down to shrink them, and drag up to fatten them.